Well, yeah, welcome to DCG's meeting. And today we're talking about our major release for our master nodes, Dash Core version 18. We released it 2 weeks ago on August 15th. And this upgrade has a range of improvements such as performance optimizations, interface enhancement, enhanced stability, and many, many other things. And today, the core team will show you the work done and new solutions implemented in the new upgrade. And before we start, I would like to remind that you need to upgrade your master nodes till this Thursday to avoid technical issues in future. And now let's get started, and let me pass the word to Sam, DCG CTO.
Hello, guys. I'm very excited about this release that should be happening on the 13th of September. And we've prepared, Virgil, Pasta, and Odysseus have all prepared a nice presentation to go through all the features that are present in V18, and I hope you will enjoy it. So without further ado, I'll pass it on to Virgil. I'll talk a little bit later at the end of the presentation about how V18 how rotation came about, and well, I'll talk about it a little bit now. Back a long time ago in when we came out with V14 and we introduced the first iteration of quorums, and then in V15 InstantSend. InstantSend had a small issue, but it was so much better than what we had previously. So we kind of realized a small issue, but thought to ourselves, well, it can't really hurt us because first, it's better than what we had before, and also because, well, the issue causing a double spent InstantSend would not actually negatively impact the chain. It would allow, theoretically, InstantSend to be double spent, but still only one InstantSend would actually take precedence. However, in platform, we use InstantSend for deterministic finality. And because of that, we had to make InstantSend so secure that basically it was impossible to, or practically impossible to break. So how we do that is going to be now presented by Virgil.
Hello. Present myself first. Normally none of you have seen me yet. I'm head of research. I've been in the company in Dash group since a year or so. My background is that I'm a mathematician. More specifically, I'm a cryptographer, which means that I do mathematics that are applied to computer security, obviously. Same cryptocurrency, obviously. I'll be talking about rotation. My rotation. Can everyone say it well? Yes. Some feedback. Anyone? Sam, do you see my? Okay, good. So I'll be presenting more the theoretical part of this update. The main feature of this update, which is rotation. So security part of the update, as Sam mentioned. Normally, we should have some link to the tip which corresponds to what I'm going to present in the description or in the comments. It will be posted to get the documents, be able to read. No worries about that. First, I'll go over double sign attacks, what we're actually defending against, how it works, so on. So I'll present afterwards the solution, which is rotation. Finally, I'll talk a bit more about how those attacks fare against this scheme of ours, how it plays in this new environment, and finally I'll conclude. Okay, first there was an attack, which was, as Sam mentioned, not very useful, but not very hard to do. First, I'll present how InstantSend are made of the locks, so that you can understand what was going on roughly. First, if you want to InstantSend lock a transaction, you have to first ask quorums to an InstantSend quorum to sign your inputs, and with those inputs, you're precising which transaction you want to lock it for. So at this point, theoretically, your inputs are already kind of locked, and then you sign the whole transaction right after. There was an issue with that, we'll see, otherwise it would be no update, is that during quorum will be renewed, and during this renewal, there will be a passation of rights to sign during this transition phase, which is roughly 5 seconds. It's not very long, but it can be longer if there's a high load on the network. You could game the system, and this was due to the fact that InstantSends are not timestamped. So there are a few issues with timestamps, and we can't really just stick them on InstantSend locks. So we had to go for another solution. Why is it abusable, and why am I talking about timestamps? Is that basically what you will do is that you would abuse this small window of time where two quorums could sign the same inputs, but those two quorums had very little overlapping. There was very little numbers in common, and as such, if you were to send the first transaction to the first quorum and second transaction with the same inputs but contradictory of a transaction to the new quorum, you could have contradictory IS locks. And you could do that because there was no timestamps. If there was timestamps, you will not be able to do that, given that you will have a first one and a second one, and this would resolve on itself, basically. And this is creating basically a possibility for contradictory IS locks. What I want to insist on is that really it's due to the fact that there are little members in common between the old and the new quorum. And I also want to insist that it's really a timing attack, that you have to do that during a small window of time. And it's only viable during those precise moments. As a reward for that former attack, which is not viable anymore, sorry, the reward was low. There was very little incentive, given that it took quite some effort still. And all that it will do would be to void in an InstantSend lock. And this is very incentive for the amount of effort. So this was the former attack and what was going on. Now we have platform. Platform requires harsher security models in general, and especially on InstantSend lock, because they are used as proof of finality. What it means is that once there's a nice InstantSend lock known by validators on the chain of platform, for them it's considered final. So if there's a possibility for contradictory IS locks, you can see that there will be huge issues that will lead to duplication of value, which will be obviously a big problem. And you could have duplicated value on the chain, and that will be very problematic. You're thinking, couldn't you just verify on the chain that everything is right? This is a bit complicated because it could still lead to some issues where you could spend your money on send it to a platform and still spend it somewhere else on the chain if you do that. So that a simple verification is not enough. You have to really forbid this possibility. You have to delete it completely. There are a few changes, obviously, with this new solution. First, solution itself, the idea, the rough idea is now you could fool quorums because there are very little overlapping members. They would not see the first transaction, so they would not be able to think, hey, I've seen something contradictory. I'm going to refuse that second signature request. So if you have a lot of overlapping members between one quorum and another, what is going to happen is that they're going to say, hey, a major part of them are going to think, I'm not supposed to sign this second transaction, there's an issue. And so this attack then becomes totally void, it's nullified. So the idea we went for is exactly that. We change only a small percentage of the quorum at a time to keep a supermajority of the members at all time that stays the same. We chose for a quarter to be changed at a time, 25%. This is the rough idea of the solution of rotation. There are a few changes that come with it that are quality of life, kind of, you could say. Now, we already had at all time set number of quorums, and now we still have that feature. We always will have certain number of quorum. Now it's 32. We went up a bit. 32 IS-log quorums, because I want to remind you that this whole setting I am talking about IS-logs, and this solution is applied to IS-log quorums. Really, rotation is IS-log specific, quorum for IS-log specific. So now they will be indexed. We will have quorum from 0 to 31, and this will make our life a bit easier for some things in the background. We will, for example, be able to request signatures. The request now for an IS-log will be a tiny bit simpler, because you will just have to decide on an index from 0 to 31. There are all changes, obviously, than just indexing. Mainly now the quorum will be renewed, not kind of randomly once the lifetime of one is finished, another begins. It won't be like that anymore. They will undergo changes at the same time, and mainly the selection of members for a quorum will always be at once. We do that for a specific reason, is that it helps spreading the load over the network. So what will happen is that those situations that will before happen, where you would have one node that is in a high amount of quorums, and it could have been too much for the node, and they would have been proof of service banned for no reason. This will not happen anymore. So you should see a slight improvement on that side. A well-maintained node will not be banned for that reason anymore. There are other things that I want to say. We have, of course, 25% that change at a time. So we have 4 such quarters, because of quarters, and the quorum will be composed of 4 quarters to make up 100% of the quorum. And obviously, one share, one quarter will be rotated at a time. If you hear me say share, it's out of habit. It means the same thing as quarter, obviously. I think that's all for the rough presentation of what it is. Really, you just take your quorum, you divide them in quarters, in 4 quarters, and you change them one at a time, so that you always have 75% that's keep in the group, and so they can check that nothing is going on during this transition period. Other than that, nothing much to say. It's a needed operation. Well, needed, so here it is. I did put a small diagram. I'm not talking much about it right now, but it showcase a bit selection of nodes for a quorum. You can see 4 quarters, some nodes being selected. Nothing special to say. Now I'm going to talk about double sign attacks in this environment. Double sign attacks, as I did not precise the name before, but the attacks where you could have contradictory InstantSend, I'm calling them double sign attacks. Now this little gimmick where you could send a request right as the quorum was renewed, you cannot do that anymore. Now, the most efficient to attack the system, I've modeled it, you have to wait for the transition period, and you will need on top of that Byzantine nodes in the quorum. This is not as easy anymore, clearly. You will need a good batch of Byzantine nodes, in fact. With 4 shares, which is what we decided upon, with 4 quarters, sorry, with 4 quarters and a threshold of 75%, you will need 25% Byzantine node in a targeted quorum to be able to try and launch that attack again. What it means, is that you have just 25% in the 3 most recent quarters of the total number of nodes in your quorum. What you will do is that you will wait for this rotation to happen, this renewal, and just before, during this window, you will still have 2 quorums that can sign, but they have a big amount of overlapping members. So what you will do is that you need nodes under your control, and you will request your nodes, and nodes that will be renewed, because once they are renewed, they're replaced by other nodes, and the new nodes will be oblivious to the fact that you have requested your first signature. Your own nodes will be not oblivious, but they will accept to sign anything they want, obviously, because they're Byzantine nodes. And thus, you need to act like that. You request in priority your own nodes. This is roughly how the attack goes in the new model. I want to point out that it's 25% in the quorum that you need, 25% of the full size as Byzantine nodes, but it's very hard to attain if you don't have at least 24.5 or 25% itself of the full network. If you don't have that, it's nearly impossible to get this amount. So you need an extreme amount of Byzantine node. On top of that, you will need an infrastructure to launch the attack. You will need hash power for a few reasons that we'll talk about later. You will need really enormous amount of power behind you to be able to attack. So it's really secure for now. The fact that you need 25% of the whole masternode network is due to the spread. We are choosing every node for all quorums at once, and what it does is that we're kind of keeping nodes from being reused in the same quorums, and thus they will be thrown in other quorums, and when they're in other quorums, they're not as easily picked for your targeted quorum. So it really forces an attacker to have exactly that amount of that percentage of the whole network as well. Second thing I want to point out is that we're continuously improving that system. It will be updated in the future for security, for optimization, so on and so on. Today, the security is already more than sufficient, but we don't want to be good. We want to be exemplary. It will be improved upon in the future. But it's already extremely hard, impossible to attack. You might be wondering, why did we divide quorum in 4 quarters? Why not in 5th and 6th and so on, so on. To those that wonder this, that ask themselves that a very normal question, it adds very little to augment the number of parts in comparison to the complexity that it adds to the network, to the whole system. It's very strenuous, and the more share you have, the more information you will have to send, notably to light clients, to mobiles, and quickly it becomes very very hard for the network, and we want to avoid that. So it's a balancing act, and 4 quarters is perfect. Final point, the attack today is not doable realistically, and I'm talking about in paper in a perfect world, and it should be even harder in reality, in fact, because on top of that, you always have network latencies that an attacker would have to take into account, and the window of time, as I said before, is short. You have 5 seconds, and a bit more if there's a heavy load on the network, but 5 seconds, and during 5 seconds, everything needs to be as you predict. So latency to all nodes must be known. This is much harder than on paper even. So the system is very, very secure.
I'll quickly give a TLDR of just that, right? Basically, we're telling the attackers how to do it. You need, let's say, maybe a third of the network, 30%. You need 90% plus hash power. And then when you have all those things, you have to create a super crazy complicated system. Basically, I think at this point, it can't happen. Somebody owning 1/3 of the network, I don't think they really want to destroy the network. It doesn't really make sense to them.
And on top of that, you have to take account latencies and the window. So
you have to hire like a massive team to build out this crazy system to get the other nodes. And yeah, it's basically not happening. This is extremely high security. So thanks, Virgil. Do you have anything else?
Yeah.
Okay, please continue.
Right. I know I'm taking a lot of time. I apologize.
No, go on.
Yeah. So as a final points quickly, it's an evolving system, so it will be improved upon in the future. IS logs are usable for platform without any risks. Rotation is specific to IS logs. And we also increase the number of nodes per quorum, for InstantSend. There's a higher threshold, for instance, InstantSend as well. And there are more of those quorums as well. So faster service, more use of the quorum. We are increasing the number of quorum because the spread now is better, so that we cannot create issues with that. We have more control over who does what. So we can increase that better for more usability on the client side. Finally, I want to precise that there's an addendum for those that are curious, more of the math part, the model of the attacker, more I forgot the word, more mathematical, more rigorous model for the attacker. But this is a bit more technical, let's say. So it's for users that are more interested. And this concludes my part of the presentation. Hopefully I did not take too much time, Sam. And questions on my part will also be at the end after Odysseus and Pasta.
Yeah, guys, we're doing questions at the very end of the presentation. And if you have any questions and you don't want to forget them, please write them in the chat and we'll get them to the, we'll get them at the end. And with that, Odysseus, want to kick us off? Well, not kick us off. Go next.
Yes. All right. Let me share my screen. All right. So you guys can see the slides?
Yes, we can.
You can hear me as well?
Yes, all good.
All right. I'm Odysseus. I joined Dash last September, and mainly I worked on v18 and essentially on the quorum rotation feature, which was a heavy one, described by Virgil. And I will introduce this feature with basically some implementation details. All right, so the math parts and the security part were covered by Virgil. I will continue with implementation details. So first of all, quorum rotation will be activated by the BIP9 style hard fork called DIP24. So this DIP or this hard fork will enable some stuff related to governance that will be presented by Paz at the end. And I will mainly discuss about the whole changes made to the quorum system. So with this hard fork, there is going to be a new LLMQ type enabled, a completely new way of creation and handling of quorums, a new quorum member calculation algorithm, so already introduced by Virgil again, and we'll have also some new P2P messages for quorum verification, basically for SPV clients. All right, so the new LLMQ type is the following one, so 6075. So with a 60 member size, minimum 50. So we'll require 45 threshold signings. So this is equivalent to 75%. And also we're going to have 32 signing quorums. So bigger than the previous InstantSend locks quorums. And also we're going to have a DKG interval of 288 blocks, which is roughly 12 hours with mining speed. So why we introduced this LLMQ? It's going to be used only for signing of deterministic InstantSend. So basically DIP22. I will leave Pasta at the end of after me, so he can present the details of DIP22. I will just stay on the rotation part. And also keep in mind that once the hard fork is active, of course, and the moment we have the first LLMQ 6075 quorums created, then we will stop enabling the 5060 LLMQs. So basically the quorums used for InstantSend. So this is applicable only for mainnet. All right, so let's simply start by presenting the way we currently use to create quorums. So for the sake of the presentation, let's suppose a simple example where we have a LLMQ with the signing quorum count equals to 4. So basically, currently what we have, every DKG interval, we create one quorum, right? And basically, the signing set is a first in, first out list of size 4. All right. So in every, let's say 24 blocks is the interval. So every 24 blocks, we create a new quorum. All right. And we keep filling the list. Once we have 4 quorums already in the list, then in the next cycle or interval, the oldest quorum is removed, and so the new one is part of the the signing set, as shown here. The new way, as already said by Virgil, is so we create at the same time 4 quorums at each cycle, and we completely renew them every interval. All right, so
completely. 1/4 quorum. 1/4 of each quorum changes at every interval.
Yeah, I'm okay. I meant you have a new the members are indeed only 1/4 changed, but we have a new quorum at the end of this cycle. That's what I meant. Are we agreed?
Yeah.
All right. So this is the new way. All right. But what happens if for any reason some DKG session fails to create a quorum? So imagine that we have a full successful cycle, and then on the next one, one quorum didn't create, and so on and so on. So this is not something that we want to keep it as it is. So we need a way to handle the failed DKG. So we introduced something called quorum index. So basically, quorum index is just an addition field on the quorum. So it's a zero-based index, really simply. And something important that since we add something to the final commitment. So final commitment is the special transaction mined into a block describing a quorum. So since we added something new, so just a simple index, we need to increase the version of the final commitment. So also the deserialization changes. And so with this new quorum index, basically we create indexed quorum in every cycle. And if some of them were not created for any reason, then we just say that the signing set is always the set of the last quorum per index. So this changes the way we select quorums for signing. All right, just also some information about how quorum hashes are calculated. The current way is simply the block hash where the DKG session started. But since now we have multiple quorums starting at the same block, the first naive idea, let's say, was to combine the block hash of the DKG block with the quorum index, and then calculate the SHA-256. But it was really really difficult to change all the code base regarding that, since it was directly using the block hash of the DKG session. So we decided to not proceed with that solution. So let me explain to you how basically the quorums are created. The idea is to start each DKG session in a spreaded way. So the DKG session of quorum index 0, we start at block B, for quorum index 1 at block 1, and etc. So the general form is the following one. So to get the quorum hash of quorum index I, then you need to get the block hash of the DKG cycle block plus I. Just a small note, I call it the DKG cycle block, the block B0 in this example. So it's the block where the whole rotation happens. And so by this solution, so we have different quorum hashes per quorum index. So we solved the original problem that we had, but also there is a small let's say okay, if you're interested in the DKG sessions, so what happens under the hood, you can read DIP 6, and you can see that the most heavy phases of the DKG sessions are phase 2 contribution and phase commitment, which I believe is phase 5. So in those phases, basically we have the most messages that are exchanged through the members of the quorum. So in this way, with the spreaded creation, then we have only two, for example, phase 2 contributions at the same time. So this is something that is important basically in, for example, small networks. So this is not really applicable in mainnet, but it was important for us to solve it as well. As I said, quorum index 0 starts at B0, but the members for all the quorums are selected at that time. Just the DKG session will be delayed. And also, I don't know if, yeah, let me put it here. Also, something really important is that all the quorums are mined and created into one block. So this is also something different from the previous way. And so here there's a small calculation. So 32 quorums, so the LLMQ 6075 are expected to be created after 42 blocks starting from the DKG cycle, because you have 5 phases of 2 blocks each and 32 active quorum count. So simply at every block where its height modulo 288, so the DKG interval of this quorum is equal to 42, then we expect to have a new 32 quorums. Also something, a detail, if a quorum failed to create, then there is a null commitment instead of a non-null mines in this block. This is also valid for the previous way, by the way. All right. As described by Virgil, we also changed the way we select members for those quorums. So for each quorum index, at each cycle, we calculate the new share, so the new quarter. I will briefly describe this algorithm with, again, a small example. So how does this work under the hood? Let's suppose that we only have those masternodes. All right. So we get the non-band masternode at height h, so where we are supposed to select the members. We separate those this list into two. So first, the masternodes already being part of a previous share, so those in green in this example, and those that are not used. And also, before concatenating those two lists, we sort them individually by a combination of, again, the block hash where the DKG session started, the LLMQ type, the protx of each masternode, and the confirmed hash. Confirmed hash is the block hash where registration of a masternode is considered confirmed. So I think it's 6 blocks ahead of the actual protx.
And
anyway.
And one thing, just for people that don't know, the protx or the protx hash is basically the identifier of the masternode.
Yes, correct. Then you start at the first masternode of the list, and you start selecting masternodes for the quorums, and also you start basically the iteration for quorum index 0. Then you select your masternodes, then you go to quorum index 1, and so on and so on and so on. Something important, since we assume that you already know the previous share of each quorum index, you're not allowed to select again the same masternode in the same quorum index. So if that is the case, then you need to skip this masternode. So you keep also a skip list of the masternodes that are being skipped for selection. And so basically, this is the algorithm. And at each cycle, we create an object that we call quorum snapshot, which is basically all the information required to construct the new shares. So we have the active quorum members. So basically, in this example, it's the masternodes in green. All right, so that would be a bit set. So true for the masternodes are already being selected. The skip list, so the entries that need to be skipped. Also, we have a skip list mode. So okay, so we have the no skipping where nobody got skipped, so we got lucky. The skipped entries, so the case that's as said, but there is also the non-skipped entries mode, where basically we have more skipped entries than masternodes. Then we need to just write the opposite. All right, so this is applicable, I think, when we have a quorum size greater than 2/3 of enabled masternodes, I think. All right, so so basically, using this quorum snapshot, you can calculate the new share for every quorum index. All right, so of course, this is a deterministic algorithm, since every node on the network is supposed to achieve and calculate the same results. So master nodes and full nodes as well. So something I think you all understood that is different from the previous way. Now to calculate the full members of each quorum, you need the members of the last 3 shares. So this algorithm is, well, I don't like this word, but I don't know how to name it otherwise. So this algorithm is what I call stateful. Okay, let me explain. So the quorum snapshot that we previously described we were thinking to include it on chain, so write all this information directly on chain, but we realized it's really really heavy information. So every node is writing basically this information on EvoDB. So it's an internal database on each node. And so basically this means that it's a bit compared to the previous way where when you jump directly into a random height, only by knowing the list of the masternodes, you're able to deterministically calculate the members of the quorum. Now, this is not the case anymore, since you need information written in the database. Last but not least, as you previously saw when we were sorting the masternode lists, we depend on the block hash where the DKG sessions start. So because miners mainly try, to mine a new block, we wanted, of course, to avoid miners to write dump incorrect quorum snapshots in their EvoDB. So we decided to, hey, when you are processing a masternode list regarding rotation, then you need to go 8 blocks behind. The value of 8 is not important, but we just need not to use the tip. All right. So we also included a new message, P2P message, for the SPV clients. So we have SPV on the left and core on the right. So when an SPV requests the gets QR info message, it passes one mandatory argument, so the request block hash. So I am requesting quorum rotation information at that particular height or block. And it can pass also a list of what we call base block. It sends the hashes of blocks that he already has information. And so the node returns a QR info message, which contains the following information. So quorum snapshots for the last 3 cycles, so that the SPV client can calculate on his side the new shares. And I am using 3 here, but it can be more than 3, because I'm reminding you the case where we have failed DKG session. So imagine a scenario where a particular quorum index is not renewed for a long time. So in that case, the node will return the extra quorum snapshot required to also calculate the members of that quorum index. Also, it returns the masternode list diffs, again for the 3 cycles or more, for the request block and for tip. And also it returns the list of the last final commitments per quorum index. And so basically this message is a quite heavy, depends on of course on the base block that you try to query, how many masternodes were added. So it's really something that we don't have a fixed size, but we will work on optimizing and reducing the probably redundant information. So let me do a recap of the enabled LLMQs. So currently, so before the fork happens, so we have the LLMQ 5060, which is used for InstantSend before DEEP24. We have the 167 for platform, 460 for chain locks, of course, and 485 for enhanced hard fork, so DEEP23. This is also going to be presented by Pasta. And so with the new hard fork, as I said, 5060 will stop being created. And instead, we're going to have the 6075 for deterministic instant send, so DEEP22. And so here you see that, okay, we created a new way of handling quorums, but it doesn't mean that all the quorums will behave like this. So here we see that only the 6075 will be rotated. Just for a quick reminder for those that are watching testnet, here's the corresponding recap. So here, what is different compared to mainnet is that here, as long as DEEP24 is active, we still continue to produce 5060 LLMQs since they are used for other purposes, for example, for chain locks. So it wouldn't make sense to stop creating them. That's all for me. So questions at the end. So thanks for listening. And Sam, do you want to add something?
No, that was wonderful. For all those people that are still watching after all this very technical stuff, I believe the last presentation from Pasta will give more about, okay, what other cool features are there in V18 other than rotation? I'm sure everybody is very tired at this point. The one thing about this presentation is that we really want to convey, I mean, and I think it's been conveyed pretty well so far. This was not easy. We created a very, very hard system to fix an issue that was very hard to fix. But now it's done. So, and V18 is going to be active. And there's only one thing that I can think of is, thank God this is over. V18 was difficult. Obviously, people have seen this complexity right now, right? So anyways, with that, Pasta, I give it to you. Let's talk about some non-rotation stuff that's in V18. This release was like over a year in the making, so.
Alrighty, cool. I should be sharing my screen and you should be able to hear me. Please confirm. Alrighty. Cool. So yeah, I'm Pasta. I am a principal developer on the core dev team, and I've been around with Dash for quite a few years now, probably I guess 4 years or so. And yeah, I'm really happy that we got Core V18 out the door. It definitely took longer than we wanted to. If you look back at the history of our release timeline, you know, we slipped on deadlines multiple times, and that's, you know, not what we want to do. But it's out, and some of the first couple of things I want to hit on is that it was a big release. We had a lot going on in V18. There were a crazy amount of backports. Over 1,000 individual Bitcoin backports were completed that bring really useful improvements that I'm going to talk about later on from 3 different Bitcoin versions, actually more like 5 different Bitcoin versions, but we didn't backport much from version 21 or 22. And V18 had over 600 pull requests in total. It was it was a big release. We upgraded to C++ 17 that enables a lot cleaner and a lot more modern code base. And we also enabled experimental C++ 20 support. We're hopeful that in the coming maybe year or so, hopefully by version 20, we'll be able to enable C++ 20 support fully. Right now, compiler support isn't quite where we need it to be, but there are a number of really cool features in C++ 20 that the team is really excited to be able to utilize, but not super interesting to most of you guys, I bet. One of the big things I'm really excited about is a significant reindex optimization. Obviously, reindexing is something that we want to avoid. Normally, you don't have to do it, but sometimes you do. Sometimes, your server gets hit by a ray from the sun and a bit flips and something crashes, and random issues happen that aren't really reproducible, or that kind of thing. And this actually results in a 38% faster reindex. So we're really, really excited about that. And then the last quick thing I want to talk about is there was a governance proposal a number of months ago asking us to reduce the governance fee from 5 dash down to 1 dash. And that was included in this version that will activate with the DIP24 hard fork. I'm going to talk about the status of that hard fork at the end of my presentation here, as well as enabling pay-to-script hash payout addresses, which are really useful, especially for an organization like DCG. We can now, once DIP24 is activated, have payouts to a multi-sig address. That could be really useful for something like, the Dash incubator, or that kind of an idea that's supposed to be more decentralized and collaborative, or even something like DCG that just doesn't want one person to have access to the funds when they get paid out from the superblock. Okay, so the first big line item that I'm going to talk about is DIP22. So we introduced DIP22 deterministic InstantSend. Kudos to Gabriel BJG. He is a community member that worked on a couple of things in v18, and one of them was deterministic InstantSend. So big thanks to him. He contributed through the incubator. And yeah, big thanks there. And from a technical level, it's relatively complex, but my part of this presentation isn't going to be super technical, so I'm going to keep it high level. Deterministic instance unlocks are deterministically verifiable into the future. That's really all that you need to understand from a high level. We basically just add on a little bit of information that indicates what quorum created the instance unlock. And so in the future, we're able to look into the past and say, okay, this quorum existed. What was their BLS key? And we're able to validate against that quorum. And conceptually, it's very simple. So there's not much here really to talk about. There was some difficulties in the implementation, and so it wasn't simple to implement, but conceptually it is pretty easy to understand. The next thing that I want to talk about is the initial enhanced hard fork support. Version 19 is going to be the first version that utilizes the enhanced hard forking mechanism, and it's a big improvement over our current BIP9 style of hard forking. And you can actually read the dip on GitHub there. I gave you a link. The problem with current BIP9 style hard forks is that only minors affect whether the hard fork itself happens. Masternodes aren't really, whether masternodes upgrade or not, isn't taken into consideration for whether the hard fork happens. And we don't like that. It creates some bad race conditions if, maybe minors upgrade faster than the masternodes, and it's just not ideal. So we're going to change it. And so EHF consists of 3 steps. And the first step is that minors signal without effect. There's a lot of text on these slides. You can pause and take a look at it later if you want, or you can read the dip. This text is basically just from the dip, compacted a little bit. But step 0 is minors signaling. And so this is useful. Basically, we can see how many minors have upgraded, but this doesn't affect anything whatsoever. The first step of consequence is the masternodes have to signal. And so we're utilizing the LLMQ 485. This is a long-living masternode quorum that has actually existed on the network since LLMQs were introduced, but has never really been utilized for anything. And so we're giving it a purpose now. And one of these LLMQs will produce a MNHF signal message that basically says that 85% of the masternode network has upgraded. this is able to be used as an indicator that proves that 85% of the masternode network has upgraded. The gist of this is that once the EHF is in effect, 85% of masternodes is what will be required to update for the hard fork to continue moving forward. So yeah, 85% of masternodes signal, and we create this message. And then after that, miners actually matter. And so at this point, their signaling matters, and it'll be basically the same as how it's currently done, where it starts at an 80% threshold for miners and it ticks down over a period of multiple weeks, with an additional change of a minimum activation height being 6 weeks out from when the masternodes upgrade. This is really useful because right now, if we talk to Coinbase or Kraken or any of our partners that kind of support Dash, they really like having firm dates that say you need to upgrade by this date. And we can't really do that right now. We can once it's clear that miners have upgraded sufficiently, but then it's only 2 weeks notice. And you kind of jump between extremes of saying, we have no idea when this is going to upgrade. It probably will happen in this range, but it really depends on when miners upgrade, to saying, okay, it's happening in 2 weeks. You need to upgrade now or else your service is going to hard fork off. And so this gives us the ability to say, hey, we don't know exactly when it'll upgrade, but you have 6 weeks, you should do it. And by this date, it will probably happen. So yeah, once miners have signaled and it is 6 weeks past when the master nodes have signaled, then the hard fork will go into effect. Yeah, EHF is something I worked on this past year. I'm really pretty excited to see this move into effect. It's really, really useful to have a deterministic way to say that 85% of masternodes have upgraded. It's a really useful tool for doing stuff like automatic proof of service for the upgrade, so that once 85% of nodes have upgraded, then automatically, there's no fork or anything, automatically non-upgraded nodes will begin being proof of service banned. The next big thing that I want to talk about is compressed headers. This is something really useful for mobile clients. And in fact, on the Bitcoin chain, syncing almost 630,000 headers saw almost a 50% space savings, from 51 megabytes all the way down to about 26, which is really, really valuable. Compressed headers is able to reduce the size of an individual header from about 81 bytes down to 39 bytes. And it's really, really useful. Probably the biggest bandwidth draw for mobile clients, and hence what can slow down mobile sync, is the header download. And so compressed headers can be really valuable. Neither Android or iOS have implemented this yet, but it is on the backlog for the mobile teams and should provide a very, very useful bandwidth improvement. Alrighty, the next thing I want to talk about are a couple more networking changes. We implemented BIP 155 as well as BIP 158. BIP 155 basically re-enables Tor support. Tor was on Tor v2 for a very long time and eventually deprecated Tor v2 and introduced Tor v3. And that was a breaking change that had compatibility issues with the way that Bitcoin and then Dash did Tor routing and Tor address handling and address propagation. And so that required a new specification, BIP 155, and that was implemented as ADDR-v2 and send ADDR-v2. So already that's working on the network. It's not a hard fork or anything, but we're really excited to bring back Tor compatibility. That's obviously a very useful tool for people. The other thing that's really useful is BIP 158, compact block filters for light clients. This is an alternative to Bloom filters. This is a little technical, but basically BIP 158 gives you a higher privacy model than Bloom filters. I think the space requirements are actually slightly higher than Bloom filters, but I'm not sure about that. Someone should be, you could definitely look at the BIP and I'm sure it would talk about it. But BIP158 is a potentially very useful alternative to Bloom filters for people who want an SPV type experience, but also want a higher privacy model than Bloom filters are really able to provide. Alrighty, the next thing I want to talk about, and I'm actually coming close to the end here, so I think I was able to do pretty quick with this and go through those nice and fast, is better Qt multi-wallet support. This is something that's really cool in my opinion. Being able to create wallets in the Qt, open wallets, close wallets, have multiple wallets loaded, everything like that is supported via the Qt. And so you can see some of the dialogues here I took some screenshots of. And so it's really easy to just create a wallet. You can encrypt it from the start. You can give it its own name, stuff like that. And then it's really easy to open multiple wallets, and you can easily switch between them in this kind of drop-down menu in the top right of -Qt. I've been using it for probably 5 or 6 months now as v18 has been in development. And it's been really nice being able to have my desktop wallet loaded and also having my mobile wallet loaded, and just being able to have those on the same -Qt instance, but still keep those completely separate wallets has been very, very nice. Okay, the next thing that we're going to talk about is the governance tab that has been introduced in v18. This is another thing that I'm quite excited about. It is relatively simple at the moment. This is something that we're going to work on improving. But the gist is that you can see all the proposals on the network. You can see if they're passing. You can see how many votes they would need to be passing, all that kind of stuff. This UI maybe could be reworked to be more useful or contain more relevant information, or there are some ideas that I saw on Discord of how we could maybe rework this, and we're considering kind of how this could be more user-friendly and provide relevant information while not being cluttered. Initially, we had just all of the information that we had in this table, and it got really cluttered really quickly, and we decided to trim it down to this information that we thought was kind of the most important information. But this might change in coming versions. We're not really sure how that will be. Right now, you're not able to vote from this screen, which is something that we want to work on, but you would be able to open the -central URL or that kind of thing in these proposals, and then look at their text there, and then you'd be able to grab the vote command on -central and then paste it in the console in Qt, and you could vote like that. That is an improvement that we want to make in the future, to be able to just right-click, vote yes, right-click, vote no, if you have right-click, vote abstain, that kind of thing, if you have a masternode voting key within your -Qt. Okay, the next thing that I want to talk about is the v18 activation progress. We released v18 about 2 weeks ago, and current miner signaling is actually at 90%. Miners have done a very good job upgrading. Masternodes have also done a pretty good job upgrading at 73% on version 18. And the proof of service fork will be activated on September 1st. And so at that point, non-upgraded masternodes might start receiving proof of service bans. And so we really, really would recommend upgrading as soon as possible to avoid getting proof of service banned and losing payments. Based on current miner signaling, we're expecting the hard fork to lock in on September 6th and then activate on September 13th. So that'll be very good. That'll be for kind of activation speed. I think that's almost exactly a month after we released is when activation would be. So it's actually a little quick. And that's one of the reasons why we are implementing that 6-week kind of delay in the enhanced hard fork, is to help avoid situations like this, where for some partners, a month is a lot of time, but for others, it might not be enough time. And so kind of giving a 6-week buffer guaranteed is useful in the future. But for v18, this is what it looks like. These are the expected hard fork important dates as well as the block information there. If minor signaling substantially changes, this could change still. This is not guaranteed, but based on current progress, this is definitely what I'm expecting. All right, now that we've dealt with v18 activation progress, we're going to look forward at v18.1 and v19. So v18.1 will be released in the pretty immediate future. We're planning about 2 weeks after activation or somewhere around activation. So that's somewhere between 2 and 4 weeks from now. We are getting ready to throw it on some devnets and testnet and test it. It doesn't include any major features. It doesn't have breaking changes, but it does include quite a few Bitcoin backports and quite a bit of refactoring and performance improvements. v18 has been in development for quite a while, for too long. And a lot of that time was actually spent working on v18.1 and v19 features while we were figuring out the issues with quorum rotation. And so v18.1 is going to be released soon after v18 and actually contains a significant amount of changes, but nothing that is breaking. Yeah, v18.1 coming out soon. We would like to get into a schedule of more frequent releases that are non-breaking. Preferably, after v19, it'll be a schedule of about every year there'll be a breaking upgrade, and we'll have non-breaking upgrades every couple of months, and move more towards almost like a continuous deployment type system where we are giving normal releases that bring improvements to people. And then, so the scope of v19, there's a lot in v19, but the big ticket items are really the migration to the new version of the BLS library, asset locks and asset unlocks. This is a feature required for a platform. It basically is how you move funds between the two systems. We would like to provide additional masternode and governance functionality in -Qt. Think almost like DMT, have the ability to create masternodes, the ability to update service, the ability to vote, all of that kind of stuff in -Qt without having to use the console or anything like that. And then full enhanced hard fork implementation. Like I said, v19 is expected to be the first version that uses the enhanced hard fork mechanism to hard fork. All right, that is basically it. v19 is expected to have a beta at the end of September. So we're expecting to be roughly feature complete at the end of September, and we're going to put that on devnets and testnets around that time. We don't have a timeline for mainnet releases at this point. Okay, I think that is it for me. And so I will, yes, Sam?
Like to make a slight correction. You said that we were fixing the bug in v18 based off of rotation. The longest bug was not rotation. I want to basically it's not fair to Odysseus to say that it had nothing to do with rotation. The one that where basically we were getting proof of service bans because of P2P bans, that was not rotation based.
Okay.
Anyway.
Yeah. Alrighty. So I'm gonna stop presenting here, and we can throw it back to probably Marina, and we can take a look and see if there are any questions to deal with.
Yes, sure. Marina, you there?
Oh, sorry, my phone is up. Yeah, I'm here. And if you guys have any questions, we can cover them. So we had several questions from Reddit. We can start with these questions. So what do you think?
Sure, let's go. Why don't you ask the question, and then we'll figure out who should answer it, okay?
Yeah. All right. After activation of v18, can we expect the v18.1 to be released to Dash mainnet when?
Oh,
How soon?
when 18.1, well, Pasta just answered that, but I'll go quickly. Basically, when activation happens, so 18 happen, version 18 happens, then within 2 weeks, we'll have 18.1.
Yeah, and
there's no need for a hard fork. There's no need for miners. It's not a hard fork. So it just has performance improvements, but no activation required in 18.1.
so how soon may it happen?
Well,
It'll probably be about 2 to 4 weeks from now.
yes,
It'll be in that range.
All right.
it will be in the month of September, second part of September.
And how about v19 work scope? So what needs to be done in that case? What do we need for that? And so
well, we just answered the questions, but basically I'll add just a little bit to what Pasta said. V19, the biggest thing with V19 is that it ships with platform. It together, right? So
yeah,
and it activates with platform. So we need V19 and platform to be ready together. In my opinion, they'll probably be ready around the same time or close to the same time. So that's basically where V19, so that, basically all the platform needs to be finished, needs to be tested, and then V19 happens. And V19 is really mainly features for platform. If we get into a situation where platform's not ready, then we'll probably do V18.2 or V18.3, which will have basically Bitcoin backports and performance improvements. So we release more continuously. But the features in V19 for platform, well, they're going to be released with platform, obviously.
so what are you guys focusing now in terms of Dash Core and in terms of platform? What are your priorities right now? That's the question from Reddit.
Again, Pasta just answered that one. It's BLS signature improvement, asset locks and unlocks, because we have to transfer value from Dash payment chain to platform, and then from platform chain back to Dash. So basically, that's the main feature from Core and V19, and then the BLS upgrade, and then there are backports, and then there's also the second part of the deterministic hard fork. But I would say that the asset locks and unlocks really are the biggest, most consequential thing in V19. Would you agree, Pasta?
Yeah, I would. So Quizzy is specifically asking about after V19 with that question of what will we focus on. One of the things that he specifically questions too is trustless masternode shares. The scope after V19 is not super clear yet. There are quite a few things on the backlog, but what will be the immediate priority after V19 isn't super clear. Trustless masternode shares or moving towards trustless masternode shares is something that we would like to make progress on. Whether that will be the priority or not, it's hard to say at this point, but we'll get better clarity on that as we move through the V19 development process.
Yeah, exactly. Thanks, Pasta.
Mm-hmm. And do we have some adoption rate progress now on V18?
Yeah, I think I handled that pretty well in the presentation there. There was a question in the YouTube chat that I would like to address. Says, are these info presentations going to be held regularly from now on? If yes, how often? This is something that we would like to do for every major release at the very least. There are thoughts internally about maybe doing more frequent calls than that. And so that is something that I would like a bit of community input on, and really see how valuable that is in your guys' opinion. There isn't a lot that we normally are able to show. There's a lot going on, but it's not very showy. And so if, you know, there is a very strong demand for maybe monthly or every other month kind of updates, somewhat similar to this, but probably smaller, that might be something that we can do. But definitely we would like to have this type of call every major release moving forward.
All right. All right. Looks like we don't have any questions so far. Well, let me check that again. Okay. So, yeah. Oh, looks like we do have a question. So, I'm not sure if this is applicable to v18, but yeah. All right. Let's
What's the
answer this question. The question from one time on Discord. Can we answer this right now?
How much of Dash supply will become platform credits? What factors determine how much it will be? That's a good one. One time, yes, I can answer that. It's as much as people want to put in credits. It's up to users. Users basically take Dash and they it's not really transform it because it's actually held, but they transfer it to platform, and then they can always transfer it back out of platform. The advantages of the payment chain is that the payment chain is extremely good for payments. Payments can InstantSend basically can make things happen in like 1 second, and things can be, you know, not as our payment chain is not account based, it's UTXO based, so it's a little bit, even if you're not using CoinJoin, it's not very obvious based off of addresses the money transmission. So it really, the payment chain is made for payments, and the platform chain is made for data storage and eventually smart contracts and I mean various other things can happen later. But you know, each one really complement each other. There is another part to this. When there will also be a masternode reward split where 50% of credits, 50% of rewards will be rewarded to masternodes on platform. Now, masternodes can decide on the difference of mainnet of the payment chain. Rewards on platform happen every 18 days for pretty much everybody, and this, I mean, people can withdraw it right away. There's nothing stopping people to withdraw it. In fact, most likely masternode owners will get a little bit more than they did before, potentially, those that are running platform. And but yeah, basically this will be automatically transformed into platform credits. So but once again, like, basically you can think of platform credits as just wrap dash on platform.
All right. So I think we're done with questions. So if you have more questions, feel free to ask them on Reddit, Discord, or Twitter after this live stream. So yeah, thank you guys for watching, and don't forget to upgrade your masternodes, and see you soon.